Hello, class. Today we're going to talk about some properties of equality with our equations. We're going to work us on some more with equations and look at a few application word problems that deal with equations. So, as we're continuing our study in this unit, there are some properties that we have been using to help us solve equations. So, if you recall, when we started, we talked about the opposite of subtraction was addition, the opposite of addition was subtraction, and then inverse operations were multiplication and division. So we're going to look at those four first. So if you had a problem and it said if x minus 3 equals 5, okay, and then your next step says x equals 8. What they did in this problem is they used the addition property of equations to solve that, because notice that you add 3 to each side. So that's called the addition property of, sometimes you'll see of equations, sometimes you might see the word equality, but equality means an equation, okay? So remember, it's what you're doing to each side to solve. So the addition property is because we added that 3. Okay, let's change that a little bit. Let's say if x plus 3 equals 5. So in order to solve this one and get x equals 2, we would undo the addition by using subtraction. So 5 minus 3 would give us 2. So that would be the subtraction property of equality, because we subtracted that 3 to both sides. Okay? So with multiplication and division, let's say if x over 3 equals 15. Okay, think about how you would solve that for a minute to get that answer. So if you remember, to undo division, we multiply. So in this case, we would multiply by 3, where those would cross out. So that would be your multiplication property of equality. So then you would do 15 times 3. And I hope you got 45 for that answer. Okay, so your property deals with what you're doing to both sides. Okay, you don't look at the problem, but you look at how you solve it. So you're really looking for the inverse operation. So if 3x equals 15, see if you can put down what x would be here. So think about what you would do to undo the multiplication. So I'm dividing by 3, so x would be 5. So that would be the division property of equality. Okay. Now with reflexive, if you recall when we studied the reflexive property, that's where you have the same thing equal to itself. Okay. So if you have on an equation, because you're going to see some today where it's going to be identical, and sometimes you're going to have no letter to solve for. So you might get something that looks like this: 3 equals 3. Okay. Now that would be a true statement. Notice nothing is changed. It's just these two constant numbers equal each other. Okay, so you're going to have the exact equal to the exact. So you could have what's called an identity in equations, which means you have the exact same things set equal to each other. So if you think about that and you're trying to figure out what your x is, well, if you take that x and you add 3 to it, you'd do the same thing on the opposite side. So these two problems would always be equivalent, which means that x could be any number in the world. Okay, so sometimes you can have what's called an identity, or every number is going to work, which is all numbers. Okay, with your symmetric property, sometimes in an equation you're going to get something like this: 3 equals x. And you probably saw where I've turned that around. Okay, so you would just turn that around and put your x in front. And it's okay to do that because with symmetry you can turn things around. So if you were to have, we'll say -4 plus, we'll say 10 is equal to 2x minus 4. Okay, you could turn that whole problem around if you didn't want the x to be on this side. So you could turn it around and put 2x minus 4 equals -4 plus 10. So it's okay to turn things around with equality. You don't change the signs, you just turn the problem completely around. Okay, let's go to substitution next. With substitution, if you recall, that was in Unit 1, and you see that kind of come back up a lot. It's where you replace things. If you know what x is equal to, if the direction said if x equals 2 and y equals 3, and it said to solve this problem, we'll say 2x plus y. What the substitution property in algebra tells you to do is you can take those numbers and replace x with that 2, and you can replace y with that 3. And then you would just work that out. So 4 plus 3 would come out to be 7. So substitution is just replacing something with something else. Okay. Now transitive. Transitive property tells you, just say that if we had 5 equal to 2 plus 3, okay, and 2 plus 3 is also equal to 1 times 5. Well, if 2 plus 3 is equal to that 5, and 2 plus 3 is also equal to 1 times 5, then that means that 5 would equal 1 times 5. Okay, let me show you an example of when you might would see that. So if you had like y equals 2x minus 3, and you had another y and it equals 4x minus 2. Okay, what you could do is you could take these two y's and set them equal to each other. And then you would be able to solve for your x. So when you solve for x, we would subtract 4, and that would be negative 2x. Add the 3, that would give you 1, and x would be negative 1/2. Okay, so that would allow you to set those equal and figure out what your x would come out to be. Now, if you wanted to figure out your y from that, then you could use your substitution property that I talked about, and you could plug that in back in for your x. So you could substitute that now and do 4 times negative 1/2 minus 2. And you would see that would give you negative 4. And if I substituted it into the other one, 2 times negative 1/2 minus 3, you see we also get negative 4. So that's pretty cool. So when you look at that right there, that's how those two kind of work together within algebra. Now, if you understand how to solve these equations that we're fixing to solve together, you could pause the video and restart that back up and check your answers. But I am going to kind of go over some special cases and some things that sometimes students miss, okay? So I'm going to go ahead and do my little dotted line that I've been doing. And I notice my x's are on opposite sides. I always like to move my smallest x. So the smallest one's going to be the one right there with the negative. So I'm going to use the addition property to add that to both sides. So that's going to be 2. Remember, that's 2 plus 2. So that gives you a 4. The negative 2 and positive 2 cancel out. So we're left with 8. Now I'm going to get the number to the right since I moved the letter to the left. So I'm going to use the addition property again. So I have 4x equals, add your 8 and 4, divide by 4, so x would equal 3. Now, when you are checking this, you would use the substitution property, and you would plug the 3 in for the x and get a number on that side. You would plug the 3 in for that x and get a number on that side. And you should get the reflexive property out if those two things are identical. So if I did 2 times 3 minus 4 and negative 2 times 3 plus 8, that would be 6 minus 4, which is 2. Negative 6 plus 8 would be 2. Notice they're identical, so that gives me my reflexive, which tells me 3 would be my correct answer. Okay, go ahead and try number 2. That's something we was working on the other day, where you had to distribute. So make sure you're multiplying what's outside to everything on the inside. So that's going to give us a 3y minus 6 minus 6y plus 2 equals 53. Now, notice that when I do my little imaginary line down through the equal mark, I have a bunch of stuff on the left side that I need to put together. So I need to clean that up. So I'm going to clean up this part here and put those together. The number is directly to the left. So that's 3 take away 6, which is negative 3. I have negative 6 plus 2, which is negative 4. Now I'm going to add the 4. So now add 53 plus 4. Divide that by negative 3. And you should get negative 19 for your answer. Now, if you're checking that and you want to substitute that in, you would have to go back. Always go back to the original, because if you make a mistake through some of the other math and check it there, you might not actually get the correct answer and it checks out right, because you could have made an error. So it's important to go back to the one that was given, okay, the original problem. So I'm going to do 3 parentheses, negative 19 minus 2, and I'm going to close that. I can type all this in the calculator like we did with order of operations. Then I'm going to do -2 parentheses 3 times -19, and then -1 and close the parentheses. Notice that I should get out that 53, and since I did, I know -19 would be my answer, so this would be the answer that I would choose. Okay, always check these because that will ensure your accuracy. Okay, going to the back with fractions. Fractions is not always the funnest thing to deal with, okay? So when you're dealing with fractions, you do have a calculator, so that's going to make it a little bit easier for you, but you've got to be careful on how you type these in, okay? So I'm going to go ahead and do this dotted line. And I'm going to think about this in terms of 50 cents and a quarter, okay? So I'm going to go ahead and subtract the 1/4. Now, some of you can do that in your head. I'm just going to remind you on the calculator. So we're going to have 1/2 and we're going to subtract 1/4. And I'm just going to change it back to 1/4. Don't forget to bring down the -3/2. Okay, now I'm going to subtract the 3. So I'm going to type in -3/2 minus 3. Math, enter, -9/2. Multiply by the number on the bottom, or you could cross multiply at this point, okay? So when you have the proportion, which is one fraction set equal to another, if you remember the other day with proportions, you would put this x with the top, okay, and you would cross multiply. So this would give me 2x is equal to -36. Divide by 2. And you would get -18. Now, if you decide to divide by that 1/4 to the -9/2, it's very important that you use parentheses around that when you're dividing the fractions, because otherwise you will mess up when you're using a calculator. So notice that gives you -18. So if you divide a fraction, make sure you put parentheses. Now, if you substitute this in to check it, you would have to substitute it into 2 parts. So you would do the x here, and then you would do the x there also. And those two things would have to be equal. So I'm going to do 1/2 times -18, and it was adding 3. So that gives me -6. And then I'm going to do 1/4 times -18. And I need to minus 3/2 to that. That also gives me -6. Okay. Now we're going to look at some special cases that some people tend to miss sometimes, because you have sometimes you get answers of no solution, or you might get an answer of infinite solutions, or you could get an answer of 0, and 0 is actually a solution. Okay. So first of all, I'm going to distribute. So that's going to be a 2x minus a 4. Now, what you notice right here is the reflexive property. So I notice I have the same thing on both sides of the equal mark. So sometimes that's referred to as the identity, because it's the same thing on each side, and nothing's unique about it. So when I look at that, any number in the world would balance there, okay? So I'm going to show you, in case you get to this situation. If you subtract the 2x, you're going to notice that you get the same number equal to the same thing, okay? And -4 will always equal -4. That's a true statement. Some people like to go even further and they add this. And 0 equals 0, which is also true. So what this means is all real numbers. What that means is it does not matter what number you substitute in for x. Does not matter. You will have the right answer. So any number in the world is going to work. So let's just try that. I'm just going to randomly pick the number 15. Okay. If I pick 15, I get 26. Would have to put it in on the other side. And notice I get 26. So whatever number you put in, it will always work. Sometimes you'll hear people put this, which is infinitely many solutions. That stands for infinite. That's the infinity symbol. Okay. Going to number 5, I'm going to bring down the left side and distribute the right side. So that's -3x plus 12. Okay, I'm looking at this problem. I see those two things are the same. Those two are completely different. So let's see what happens here when I use the additive property to add that. Okay, my letters go away. Will 2 ever equal 12? No. If I think about this and I actually go one step further, this side's always going to be 10 more. So that will never equal each other. Okay? So what that means is no matter what number you put in for x, it will not work. So this would be considered a no solution. Sometimes you will see that written as the empty set. Okay? This would be considered the empty set. Never put a slash through 0 unless nothing works. Okay? What that means is nothing works in that problem, not even 0. Okay? If I was to put in 0 for that problem, I would get 2 on that side and 12 on that side. Those two do not equal each other. So you will never find a number that would work there. That's what no solution means. Okay, and then number 6, that's a -1, so it's going to change both signs inside when I multiply. Okay, this time I'm going to add the x over here. One x plus 1x is 2x. Okay, remember my goal is to try to find something for x that would make this work. So I'm going to subtract my 3. 3 minus 3 is 0. Divide by 2. So this time I'm finding the number that would give me a balance would be when x is equal to 0. So let's see if that would work. That gives me a 3. There we go. Still kind of shining bright. Let me see. And then if I do 0 plus 3, that gives me 3. So that would work. Okay? So the note, if you have no variable left, which means that both variables cancel. You have to look to see if it is true or if it is false. If it is a true statement, it's all real numbers. If it is a false statement, it is no solution. Now, I want you to look up here at the ones that I'm talking about that was the special cases. Notice that both variables canceled out. I didn't have a letter left. Remember, a variable is a letter. Both of these variables canceled out. So that's when you have to determine if it's true or if it is false. Okay? If it's true, it's this one. If it's false, it's the no solution. Notice in this last one I did with you, the variable did not cancel out. I still have a letter. So when you still have a letter, you can get an answer, okay? The only time that is the case if you have no variable. They're both canceling, okay? So now we're going to look at the last page, which is 2 word problems. Okay, this says the sum. Sum is a keyword, which means add. 5 times a number. We don't know what that number is, but we know we're going to put it as 5x. Remember, when the 5 is written in front of the x, that signifies multiplication. And we're adding 25 to that. The word is means equals. So we have 5 times a number plus the 25 is equal to 50. I'm going to go to the side and we're going to solve that. So I'm going to subtract 25. $50 minus 25 would be 25. Divide by 5, so x is 5. So if I check that, 5 times 5 is 25, and 25 plus 25 would be 50. Okay, the length of a rectangle. I would draw a picture. We're going to draw a rectangle. The length is going to be the longest side. Remember, they're going to be equal to each other. And that would be my width, and those are equal. The length is 5 more. The length is 5 more than. That means add twice the width. If you hit a double, you would be on second base. So twice the width means 2 times the width. So my length is going to be 2 times the width plus 5. So the length is twice the width plus 5. Okay, now the opposite side has to measure that too, because you have 2 lengths. Now we have no idea what the width is, but we know it's going to be W. So I'm going to put a W there. So I've got all 4 sides of the rectangle labeled. The next keyword is perimeter. Perimeter means that you're going to add all of the sides. So you're going to take every side of this rectangle and you're going to equal it, because we have the word is, to 118. Okay, so I'm going to set my equation up. I'm going to come down here and do some work. So I have a 2w plus 5. I have another 2w plus 5. That's my 2 lengths. I have a width, a w, and I have another width, a w. So that is equal to 118. Now notice all of those are on the same side. So I'm going to simplify my life and combine these like terms. So I have 2W plus 2W. That's 4W. 4W plus 1W is 5W. Plus one more W, you should have 6 W's. Then we have the constant number of 5 plus 5. That should add to give us a 10, and that equals 118. So that would be my equation, 6W plus 10 equals 118. Now, when you see how to do this, you could just add around the rectangle. It'd make life a little bit easier. So you could go around the rectangle and add up those W's. And you see I've highlighted that. There's a 1 in front of those when you don't see the coefficient. So that would give you 2, 3, 4, 5, 6. And then add your 5 and 5, which is 10. Okay, now you're ready to solve it. We're going to subtract 10 using the subtraction property to get it to the other side. You're going to do 118 minus 10. It's going to be 108. Divide that by 6. You're going to have 18. Now, you have to figure out what that stands for. Well, it tells you right here. That's the width, right? So my solution is the width is going to be 18. Don't forget to put the units. This is in centimeters. 18 centimeters. The length. Now, to figure out the length, you have to use that substitution property. You have to plug in 18 for the width. So you have to do 2 times 18 and add 5. So go ahead and do that. You can type it all in just like with the order of operations. And that gives you, I believe, a 41. Okay, 41 centimeters. Now, I always like to make sure it checks. So I'm just going to go around the rectangle and put these numbers. So we have an 18 and an 18 and a 41 and a 41. Okay. So you can add this, or if you remember your teacher in the past, if you don't want to add 41 2 times, you can multiply it by 2. And if you don't want to add 18 2 times, you can multiply it by 2. So notice when I put all that in, I get 118. Or you can type in 41 twice and 18 twice, either way. Okay, make sure that you turn this in from today's lecture and make sure that you're working on your assignments. I hope you learned something new today that you didn't know about equations. Have a wonderful day.